Hello, and welcome to Tech presented by Kaizen, where we will explore common cleaning questions and answers. This session has been pre-recorded and will include additional FAQs related to this specific topic at the end of the presentation. We hope it is 15 minutes well spent. Let's get started. I would like to introduce Kaizen's own Ethan Mueller.
Thank you, William. Hello, and welcome to today's Tech to Tech session. Today, we're going to be discussing using a humidity chamber for corrosion testing or performing a corrosion study. There's a variety of different chambers in industry, and when it comes to parts cleaning, one of the more common chambers that we are interested in is the humidity chamber. And so, what a humidity chamber does is it provides us a controlled environment for testing. And so that chamber that we have, we can adjust the temperature, we can adjust the humidity, and there's a lot of different parameters that we can play with to look at what's going to happen to our parts in the field. And really, the purpose of this is that it's allowing us to have an accelerated view of time. So 1 day in the chamber is roughly equivalent to 9 days in the field, e.g., an accelerated test. The there's many different humidity chambers, varying sizes, different parameters and stuff. The one that we have at Kaizen, it allows us to work from 10 to 98% relative humidity. It allows us to go up to 90 degrees Fahrenheit. And those are kind of the settings that we run our tests at. And typically we run a test for 10 days, which is roughly 90 days in the field. So a corrosion study, what is the purpose of a corrosion study? Well, really the purpose of a corrosion study is to investigate your part or whatever material your part is made of, investigate how long it takes for that part to experience or that material to experience corrosion. Um, so essentially what we're doing is we're trying to give a customer a sped up view of how long they can expect to store their parts without those parts experiencing any corrosion. And it also gives us ways to look at, it also gives us some ways to control our in-process corrosion. If we have flash rusting or something like this, from one assembly or from one process in the assembly to the next. So running a study, there's a couple of different things that we need to do. And the first thing is we need to collect parts or representative coupons of what your parts are made of. Typically, we would get this from you. The coupons, that is just a square, if you will, a cutout square of the material that your parts are made of, and we can use that in lieu of the parts. Um, Coupons, they're certainly not ideal for testing, but they're a really good substitute when we have large or expensive parts or parts that we're just not ready to send out into the public's view. The parts that we're going to be running the study on, they need to be clean. They need to be representative of what is coming off of your production line. In testing purposes, if we can have you clean your parts and send them to us cleaned, that would give us the best representation of your production parts. Or maybe you have some sort of specification that we can meet on our end, and then instead of you cleaning the parts and sending it to us, we can have that spec and we can clean it in house and then use the parts that we cleaned in house in the humidity chamber. An example study, this is just a study that I sanitized, to show you kind of the differences that you can experience when you change the concentration of the RP. That's typically what we're doing is we're applying an RP to parts and then we're putting it in the chamber to see how long the RP will protect those parts. And so in this study, the customer was looking for 6 months of protection, and that's why we took it to 22 days in the chamber. And test one is 3% concentration, test two is 5% concentration, and test three is 7% concentration. So as you see in test one, that's that 3% concentration that we had. After about 18 days, we started to see rusting. So now you jump that concentration up to 5%, and now it takes 20 days for us to experience rusting. And if you look, you can kind of see that the rusting seems to be a little bit less and maybe not as how do you say, not as it hasn't spread as far as it did with the 3% RP. And now we're gonna take that one step further, and we're gonna jump it up to that 7% concentration, and as you can see, we almost made it all the way to that 22 days without any corrosion, and so what that is essentially telling us is that this customer could take their part, apply a 7% RP to their part, and put it on a shelf for approximately 6 months without experiencing any sort of rusting or any sort of corrosion. And as you'll see, after 22 days, this part came out with one little spot. And as you can see, it's much smaller than the other spots, and it's just starting to propagate after 22 days of being in the chamber. So that's pretty good. That's what we would consider um, long-term protection. Typically, we say that these RPs are good for 90 days, but the customer needed longer than that, so we just did a test and we studied. We did the study, and it came back, pretty close to what they needed, and that was good enough for them. So now that we've ran the test, we have some results that we have to interpret. And again, 1 day in the chamber is roughly 9 days in the field. Or if you take that out further, 10 days in the chamber is 90 days in the field. And of course, this is dependent upon your local climate and the storage conditions. Of where your parts will be and how they're stored. But from there, we're going to use these results to optimize our production process. You know, optimize that RP coding. Maybe a customer says we only need 10 days of protection. And so when we do this test, we find that, well, 3% gives us well beyond 10 days of protection. And therefore, the customer has the ability to see that and say, okay, we're going to run 3%, and that's going to save us this much on chemical, and so on and so forth. The other thing is tells us kind of what our storage needs are. If we're in a very tropical climate, this might tell us that we maybe need to put our parts into some sort of controlled storage, something with humidity control. And then the other thing that this allows us to kind of consider is what is the part's end use? You know, when we consider that, it allows us to determine what percentage we need in RP. If a part is going into an assembly or something like this, typically an RP is a good solution to preventing corrosion. However, if it's going to be exposed to the elements forevermore, we might want to consider something other than an RP, something such as painting or plating, um, or some sort of metal finishing along those lines. So after the study, our work isn't done. When we have a part that has RP applied to it, we need to ensure that we properly handle our parts and we properly store our parts. And so we want to minimize handling of parts, minimize the contact between parts stored together, because physical contact will obstruct that coating and allow you to see a more rapid corrosion. And if people are handling the parts without gloves or something like this, a lot of times you'll see a little rusted fingerprint into the surface of the parts, and it's pretty easy to figure out who the operator was that was doing that. Avoid direct contact with rain and water. This is key. RP, is not really designed for direct contact with water. They will rinse away. It will significantly degrade the amount of protection that you can that you can the amount of protection that you can expect will be degraded. If you are in this scenario where you might have your parts rained on, or maybe there's some water that's coming into contact, you might want to consider a water displacing type of film, or a wet film. These can handle direct water better than the dry films can, but again, they're not really designed for that. And finally, one more thing that we can consider to reduce our corrosion or our rusting or something like this is we can store our parts in a climate controlled warehouse. When it comes to RP, this is certainly helpful. It's going to give you a longer life with that RP, but it's really not necessary. Once again, these RPs are designed to protect our parts from the elements, and typically that's the reason we're applying them is because they are going to go into a warehouse that isn't climate controlled. Again, if we are doing things other than putting these parts into assembly, or we're just having them on the shelf for a few months, we might want to consider something other than just applying an RP or a CP. We might want to consider painting our parts or plating them or doing some sort of metal finishing that's going to protect them long term. RP is really just a placeholder for the interim, but beyond that, we want to do that painting or that metal finishing. A nice little mention here. Typically, the dry film products, the dry film RPs and stuff like this, you can paint directly over those, and you'll get great paint results. It won't do anything to inhibit your adhesion. So it's just a nice feature of those products. In conclusion, a humidity chamber allows us to take an accelerated view of corrosion and how it propagates. Coupons, they're not ideal for testing, but they do suffice if we have large or expensive or parts that we just need to keep secret. And parts and coupons, they need to be representative of our production and our storage conditions. And that's going to allow us to get the best results and the best data. And then we can use those results and that data to determine whether or to estimate whether failure will occur in the field, and failure being rust or oxide prematurely. Some frequently asked questions that we might hear on this topic is, how do I calculate the amount of time I can store parts based on results found from the humidity chamber? And, typically what I would say is that the humidity chamber we were running at 90% humidity, 90 degrees Fahrenheit. Those are some of the harshest conditions you're going to find for metal parts on planet Earth. And so, unless you're in those conditions, one day is probably pretty close to 10 days in your climate. Um, what is the largest part we can do a study on? Again, there's a variety of chambers out there that you can do or that you can find. So you might be able to find a bigger chamber elsewhere. At Kaizen, typically around 18 inches by 18 inches or 20 inches by 20 inches is kind of the maximum that we can go. Anything beyond that, we're going to be looking to do coupons or maybe even cut your part into sections, something along those lines. How long should I put my parts in the chamber? So typically we run 10-day tests, and 10 days is roughly equivalent to 90 days in the field. However, you might be looking for maybe a little bit longer term of protection than that. So let's say you're looking for 6 months of protection or 180 days. All you would do is you'd simply divide 180 by 9, and that would be 20 days in the chamber. And so really that's kind of where we get that from, where we base that off of is 1 day in the chamber is 9 days in the field. So whatever you're looking for, simply divide it by 9, and that's how many days you should have it in the chamber. And with that, I would like to turn it over to William to finish up.
Thanks, Ethan. Thank you all for watching this Tech to Tech session. If you'd like to discuss this topic further or have any questions not answered in this session, please contact your local Kaizen regional manager or send an email to tech at kaizen.com, and we will have someone follow up with you as soon as possible. Do you want to have exclusive access to future content sent directly to your inbox? Or do you know someone who would benefit from these sessions? If the answer is yes, just go to tech by kaizen.com, fill out the subscription form. And if you like this video, be sure to follow us on our social media platforms for more expert cleaning content.